Well, hello, everybody. Welcome to another AgileAssets Product Showcase webinar. We host these webinars monthly, covering different products and services offered by AgileAssets. My name is Barry Raskin. I'm the Marketing Director here at AgileAssets. Today, we are talking about safety management on our roadways and how a robust safety management system can help you make better decisions that can reduce collisions and property loss and save lives. Our speaker will demonstrate how AgileAssets Safety Analyst product can help your agency meet your road safety objectives and comply with the Federal Highway Safety Manual. A few housekeeping items before we begin. This webinar is being recorded. We will send out a link next week for you to be able to rewatch or to forward to your colleagues. The slides will also be provided along with the video. The presentation today will last about 45 minutes, leaving time at the end for questions. If you have questions at any time, you can enter them into the Q&A tab in the WebEx window, and we will address them at the end of the presentation as time permits. At the end of the webinar, you will also be offered a very short survey. Please take a moment to fill it out so that we can continue to improve these webinars going forward. Our presenter today is Dr. Shafiul Azam. Shafiul has been a senior consultant at AgileAssets for over 5 years. Shafiul is a subject matter expert in highway safety analysis and management, traffic engineering, and GIS. Shafiul's recent experience includes roles as functional lead for Montana and West Virginia DOT's safety management systems, including Montana's FHWA award-winning Safety Information Management System. He's also a contributor to the development of the AgileAssets Safety Analyst module. Shafiul received his Doctor of Philosophy in Transportation and Infrastructure Systems from Purdue University and a Master of Science in Civil Engineering, specializing in Transportation Engineering from Wayne State University. And with that, I will pass this presentation over to Shafiul.
Thank you, everyone. Thank you, Barry. Can you hear me? So to make sure.
I can hear you.
Okay, thanks. So welcome everyone to this presentation on AgileAssets Safety Analyst. Safety Analyst is the brand name of our safety management system. So here's a quick contents of today's presentation. I will start off with the market problem of safety management system that our system is trying to address. Then there will be a brief introduction to the safety management system, its goal and the capabilities that we have. I will then introduce our safety management system product, which is Safety Analyst. I'll talk about the product portfolio, product highlights, and our recent implementations. Then I will provide you a quick walkthrough of the generic Safety Analyst workflow and different processes and sub-processes that is part of this workflow. And following that, there'll be a demo. It will be a short demo to reinforce the understanding of the workflow that I provided in my previous slides. Finally, I will discuss our future roadmap, and at the end of my presentation, there will be a question and answer session. Let's start with the market problem. So our safety solution is trying to resolve, most of our solution try to resolve some of the problems. So the market problem is safety is we're losing the precious life of human being on the road every day. And if you compare that, accident is the 4th leading cause of death in the United States, and traffic accident roughly is 27% of the accident deaths. In USA, roughly 33,000 people are dying every year from different traffic-related crashes. As you can see on the map, these numbers are slowly declining over the last few decades. However, the number of fatalities is still astounding. So highway crash has an annual price tag of roughly 242 billion economic loss, which is 1.6% of the GDP. So overall, this is a huge burden for the economy itself. Now let's see how we are trying to resolve this problem at the policy level. Federal government is trying to address the safety transportation, the surface transportation issues by different Transportation Safety Act. And you all know about that. We have Safety Law, MAP21, and FAST Act. And this is ensuring enough funding for the highway safety and public transportation. And the state highway agencies like DOTs, they are trying their best to come up with the best transportation investment plan that can ensure the accessibility, mobility, and safety on the roadways. There is also some international approach, and you all know about the Vision Zero. And Vision Zero has been successfully implemented or accepted in some of the European countries like Sweden. And I can give you a number that Sweden has the lowest annual rates of traffic-related fatality. It has only 3 crashes out of 100,000 people compared to like 12.3 in US. So they're making a lot of progress in accepting the Vision Zero concept. One of the 4 principles of Vision Zero is that human life and health are paramount, and it takes priority over mobility and other objectives of the roadway traffic system. And one of our implementation that is in Montana, and we know that Montana is also a Vision Zero state. So now let's take a quick definition about the Highway Safety Management System. This definition is I'm actually quoting from the Federal Highway Administration. A safety management system gives decision makers and those who manage and maintain roadways the tools to systematically identify, prioritize, correct, and evaluate the performance of the roadway of the transportation safety investment. So basically the goal of the safety management system is to reduce the number of crash, reduce the severity of the crash, and when you are making any investment, to make sure that you are getting the best return on the investment. So that's basically the idea about having a better safety management system. And why such safety management is so important? An ideal safety management system, it can help you achieve different goals. For example, it should have a screening tool to identify the location with promise, which is the hotspot where you can make the best investment and can get best return on your investment. Also, the safety management system, an ideal system, should have a diagnosis tool that can do additional investigation on the identified hotspot. And it will help you pinpoint the regions of preponderance of crashes, so you can make a better decision about your countermeasure selection. So it should identify the treatment also that are most appropriate and feasible with the help of decision matrix or decision tree. And last but not least, this should have a proactive measure to identify any roadway deficiencies that need to be fixed to ensure safety before it causes any accidents. So that's kind of the ideal features of a safety management system. And let's see how our safety analyst can help you doing that. So this is a comprehensive solution, our product safety analyst, that can enable safety engineers and safety managers improve the effectiveness of the safety program across the roadway networks. And it can answer different questions that often the safety engineers or safety manager has. For example, what should be the investments? Where should I invest my safety funds? Or what should be my performance target? Okay. And also, like if you have different divisions and districts, how you like to invest your money across these different divisions, and what should be the best investment plan if you want to invest in multiple years scenario. One of the things that is an ideal situation, like you have to sometimes make a decision about your investment, about competing treatment options. For example, if you want to invest on the rumble strip versus guardrail treatment, and which one will be economically more justifiable in terms of benefit and cost estimation, safety analysts can give you that kind of answer. This is a quick product portfolio of our AgileAssets suite. As you can see that we have a system foundation, and that system foundation, it actually gives you like different functionality, like for example, system admin functionality, security, linear referencing system, GIS, reporting, and AgileAssets API. Those are all falling into the system foundation. Then we have a manager series, And the manager series, we have like maintenance manager, right-of-way manager, sign manager. We have also signal and ITS manager. And basically the idea is to manage transportation operations and maintenance activity by this manager series. And on top of that, we have the analyst series. So idea of having analyst series is this uses the data from inventory and from the different performance measures and can generate work plan. And these managers analyst series we have for the bridge, for the pavement, and the safety analysis that we're talking today. Finally, we have the trade-off analysis tool. The trade-off analysis is on the top of this of the product, which is it makes sure that if there are different work plan generated from the analysis series, the trade-off analysis can optimize the work plan. Actually, it uses something we call the utility function. It uses the utility function to make the best investment plan across different cross-functional areas. So our focus is today on the safety analyst, this particular product. Let's give you a quick product highlights. Our safety analyst, it has a flexible data model. So it supports the MIRE and MMUCC data elements. MIRE is the model minimum roadway elements. So if your agency are trying to implement the MIRE elements to collect the information for safety, our system can support that. We also support the MMUCC element, which is model minimum uniform crash criteria. So any standard crash definitions, crash criteria, or data structure, our system can support that. We can also interface with crash data collector, citation database, injury and trauma data, DMV records, and roadway logs. And we have implemented in both in West Virginia and Montana, we have several interfaces with these external data sources. Our system also supports agency-specific safety performance function. For example, you can have a generic safety performance function that you can borrow from highway safety manual. But if you have a specific safety performance function or you want to update in future, our system will give you that capability. Similarly, the decision trees that actually you can generate in our system, that what treatment you should take when you have this particular scenario, that kind of decision tree can be configured by you, can be maintained by you, and we also allow you to use different cost-benefit functions. Our system has a fully integrated LRS and GIS capability. So if your LRS, so we have our native LRS, linear referencing system, and that actually allows us to glue different modules that we have. For example, if we are implementing pavement system and roadway system and safety in the same platform, the LRS will be actually, it will connect these different systems, and that's the beauty of having a fully integrated LRS. Also, if your LRS is maintained outside, like you have something, a different LRS management system, we can make an interface with that. We have the reporting capability. We have a rich reporting and business analyst capability, like the dashboard reporting, the standard report, graph report, and Jasper reporting. And we also allow the cross-functional integration, and I already talked about the trade-off analyst that can do that kind of integration. Here's a quick snapshot of our current customers. Our first implementation we did in Israel in 2007. And that implementation was a custom implementation, but it was part of the AgileAssets suite. So our other two implementation for Israel was PMS and Bridge. So it helps the system to run trade-off analysis using that three modules. Israel system has both proactive and reactive method. So they have defined their proactive model and the reactive model, and combine them together. The system can generate a work plan for the safety. It also has a video log, so it helps better diagnosis of the hotspot. Then in 2012, we implemented our system in West Virginia, and that was an HSM-based system, Highway Safety Manual-based system. It was part of the ERP implementation. So having that, it provides added benefits to safety management system because it can not only interact with other modules within our suite, but also can interact with other financial components. I can give you an example that West Virginia has a safety grant management system, And the grant management is actually initiating in the financial system, but that is interacting with safety management to make decision on awarding of the grants. So that is a very interesting scenario. West Virginia, these performance metrics and was very simple. We used a very simple performance measures, and that was mainly the reactive process. And we started using the MIRE elements in the West Virginia implementations. In 2014, our latest implementation that we did for Montana DOT, it is an HSM-based system. It's a standalone application, and it has the reactive method mainly. But what we did for Montana system, we actually included some of the advanced performance measures. So we have the empirical-based technique and level of service of safety implemented for Montana. We have also the MIRE elements and a new tool that we included in 2014 that is we call the diagnosis analysis tool. I'd like to mention that Montana received the National Roadway Safety Award in 2015 for the roadway departure study and safety information management system. Montana has done some study and developed its own SPF for the roadway departure crash. Finally, they used our software solution as a part of their SIMS implementation project. And this tool is currently helping them to perform the analysis using the newly developed SPF and other safety management methods. Now, I'd like to give you a quick walkthrough of our safety analyst workflow. As I mentioned that our system is an HSM-based system, so we maintain the same workflow that highway safety manual follows. So we start with the safety database management, and then we have the network screening. We have the diagnosis, the project composition and economic appraisal tool. We have the project prioritization tool. And lastly, we also do the safety effectiveness evaluation or the before and after study. So let's start off with the safety management, safety database management, how we implemented that in our software solution. So safety data elements, our software supports both safety-related data and other infrastructure-related data. Here's a list of the data set that we have already included in our data model. Like if it's a safety-related data, the crash data is actually a crash data-centric database, but you can also interact with other information. Like you can build interface with EMS and trauma center data. So if you want to link the injury outcomes to EMS record or the trauma center record, our system can give you that capability. Similarly, if you want to link the drivers and vehicle information, suppose from DMV or from vehicle registration department, we can also build that interface so it can interact with that system. We also have citation and conviction data model, and we have implemented that also for both for West Virginia and Montana. We have the safety projects and grants functionality. I already mentioned about that. In West Virginia, we implemented that. The safety grants interacting with our system. On the other side, we also have the infrastructure-related component. So mainly the roadway inventory is the main data component of that. We also support the MIRE elements, other pavement conditions, guardrail, and if there is a structure inventory like bridge or culvert, that also can be part of that. So in essence, we actually have a total package of both the crash or safety-related data and also the infrastructure-related data under the same platform. So anytime if you want to do a data analysis using interaction of these two elements, we can easily provide better answer for that. Now let's take a look about the network screening functionality that we have. Mainly we have three components in the network screening. We maintain a profile management system. We have a safety performance library or functions we use, and we also have the screening and ranking techniques. So this is the basic process step in the network screening process. There are three different steps. The first step is we create a network profile, and then we use the network profile to run the screening, and finally using the screening results, we identify and rank the hotspot. So when you create the network profile, we actually break the network into smaller pieces, and this is something that helps you to framework like different safety screening method. For example, if you have a simple ranking or sliding window or pick search technique, this creating the profile will help you achieving that. Then when you run the profile, run the screening, basically you have to select your scope, which is if you have a network scope or you have a crash filter that you want to apply, that is falling into that category. Then we have the threshold selection. So you have to consider the 95th percentile or 98th percentile of the threshold of one of the performance measure, and that is happening in this step. We also have another step called road hotspot rule selection. Everything is part of the network screening. That you have to select which performance measure you are using and what are the ways you are computing that. For example, if you have the empirical based technique and level of service of safety, you can actually specify that rule in hotspot selection rule. So finally, after you run screening, it will identify the hotspot. And what we did in identifying the hotspot, we actually, if there are contiguous sections in the screening, we actually glue them together and form clusters of hotspot instead of individual isolated hotspot. Here is a quick snapshot of how our network profile works. As I mentioned in my previous slide, there are main locations and there are secondary locations. So what we did, we take our network, we break it into homogeneous sections, we call it main locations, or we can have a list of the route in your network that can also be regarded as a main location. And within each of the main location, we build smaller pieces of the network. And these pieces can vary. It can be either overlapping pieces, like if it is a network screening with sliding window, then we have to build these overlapping pieces. Or if it's a peak search technique, it will be non-overlapping pieces. So that is all happening in the secondary profile. So once you have all the profile ready, that will push to the next item, which is the screening technique. And I will actually cover this aspect when I will show you the system. So this is basically the framework of how the network profile works. Then we also have, this is an example of the performance measure calculation that we did for Montana. I already mentioned that Montana uses some of the latest and greatest the techniques that we have, the empirical based method to compute the estimated crash and to adjust that crash count. Then we also use the level of service of safety, and there are 4 regions of that, 1, 2, 3, 4, and based on different situation, like whether your empirical base crash count is between your mean and the lower bound, or between your mean and upper bound, you can decide on the level of service of that. And there's a hotspot selection rule. When your level of service of safety is 4, we are considering that as a hotspot. So this is one of the way we can actually identify the hotspot. There are other different rules we can also apply in our system. A quick example of the level of service of safety based system that we developed. So Montana has this SPF, they have their own SPF, and our system is computing the empirical base based on the empirical base method, all these different data points, and system is also deciding whether what should be the level of service of that specific segment, and that's how it's identifying the safety, identifying the hotspot. We have a window where we can actually configure the different SPF models. So as you can see that this is an example from Montana. They have different SPFs for different roadway type and severity type, and the parameters are actually saved in one screen. And this is giving the end user or the system analyst to basically identify or make any corrections to the model or adjust any model. So it's basically a future proof. So if you have a model and you want to update in the future, our system is giving you that options. So let's talk about the diagnosis tool, our next process. The diagnosis, we actually have 3 different ways we can do the diagnosis. We have a GIS-based diagnosis tool, we have a road viewer tool, and we also have an analytical engine. We call it analytical diagnosis tool. So in the GIS-based tool, basically, we actually overlay the hotspot with other map features, like it can be roadside feature, can be road, can be hotspot, and it actually give you a better understanding about what is happening on the hotspot. In the second one, the road view or the straight line view is almost similar to the map based, but here we are looking into everything on a straight line diagram. So basically, we can plot the hotspot and individual crash and also the other roadway asset, and it can give a better understanding whether there is any deficiency in your roadway features, like if it's a guardrail missing or inadequate width of the roadway, or there is a specific median type or something else that is causing that issue. The straight line diagram will help you diagnose that. Finally, we have the analytical diagnosis tool. So basically, you can select a specific safety diagnosis norm or diagnosis factor. And the factor can be either the crash type, can be the weather condition, can be lighting condition, and you can compare that specific percentage of crashes with the average of the group. And the control group can be either your highway class, it can be the county average, or can be both, like the highway class within a county or so. Our next step is the project composition and economic appraisal tool. So in this particular tool, we actually we identify the locations of the projects, we assign the treatments for that, and you also assign the crash reduction factor, and then we can actually compose the project based on that. After you compose the project, it goes through a cycle of benefit and cost analysis, and we identify the benefit and cost, and the end user need to make a call, that decision maker or end user, whether that project should be selected or not. And the selection method of the project can be very complex, and this is something, some kind of workflow that we implemented for West Virginia and also for Montana, that we maintain different phases of the projects. Like your safety project can be just a proposed project, you just compose your project, then you have the project, you do the benefit and cost analysis, then make a decision whether your project should go to the next phase, which is the recommended phase, or it should go to the discarded project box. If you want to recommend the project, then you can add the funding source, the project phase, state project number. Then again, you can evaluate the project and make a decision whether you should really go and authorize the project for funding to program the project, or you should just go ahead and discard the project. So the next step is the program project, and finally you go to the last step, which is the completed projects. So such complex scenario or project tracking can also be implemented as part of our software. Then we have the project prioritization tool. AgileAssets is actually have a very robust optimization tool, and we have also implemented in our safety system. Basically, for the Israel system, we have this specific framework that you can have your crash data, and that is the reactive way of identifying the hotspot. We can also have the roadway features that will be the starting point. So you basically look at the safety deficiencies, and that is the proactive approach. So in either way, you do either the reactive or proactive way, you have a network, you have a need for the safety improvement. And that need for the safety improvement has some budgetary constraint, and you also need to prioritize that. So this is where the optimization is helping you. You have some safety need, you already identified your treatment, but this tool is helping you what should be your ultimate work plan based on these constraints. This is another example like how we formulate that problem. We actually consider, this is an example that how the required width and existing width of the roadway can be considered. This is one example. Suppose your roadway width, you consider that you go to the standard and found that your width should be WR, which is your required width, and the existing width is WE. And you compare the difference between that, and the difference can be either low, can be medium, and can be high. And based on what type of difference you have, you can come up with different type of treatment strategy. And this specific practice can be also done for different types of safety deficiencies. Like I provided you the example of the roadway width or the lane width. It can be also done for the median barrier, for roadside barrier, for other obstacle, median, any types of safety deficiencies that you can consider. And you can have this kind of report that shows you that for each of your segment, what is the condition? Is it low, severe, or high, low, medium, or high severity? So if it is a high severity, that means there has to be a lot of improvement for that particular section of the roadway. So once you have this particular framework, you basically put this framework into our analytical engines like our optimizations, and you come up with something like this. Like you can have your unlimited budget conditions, whether, for example, in the previous example I showed you, there are 65 sections, and you come up with 580 treatment for that. If you have unlimited budget, you'll probably go ahead and implement everything, and that will probably give you like the cost will be 25 million. But if you have a limited budget condition, there are a couple of examples I have here, like it's with 16 million or 10 million, then you'll not be able to implement all. You'll probably implement or improve 47 sections out of 65, or maybe 32 sections out of 65 with reduced number of treatments. But in the long run, you can compare the benefit and cost. Like, for example, if you go with this, the lowest constraint, like this $10 million budget constraint, even you are getting a higher benefit and cost ratio. Although you are not touching many of the segments, but this is again giving you a better estimation how you should proceed on, given you have a budgetary constraint. Or finally, I'd like to talk about our safety effectiveness evaluation. There are actually two ways we can achieve that in our system. The first method, we call it the plan versus actual benefit and cost analysis. The way it works, we actually have the framework in our system. I already talked about that one, that we can track the project up to the completed project step. So after the project is completed, we can actually compute the economic benefit or economic return on investment, and we can actually compare the planned benefit and cost and the actual benefit and cost of that project. And this is very similar to the before and after study. We can also do the conventional before and after study, and that can be done by using some kind of reports. And that can be two different scenarios. In the first scenario, you basically have your section itself, and you're just waiting after your safety investment is completed, your countermeasures are implemented, probably waiting 1 more year, and to see what are the benefits whether or not you're getting any benefits of that investment or not. On the other hand, you can also compare different control segment, and an example is like that you have your treatment group, which one has received the treatment, that is shown by the solid line, and the other dashed line, this is the control segment. So you can see how after applying the treatment to the treatment group, you're basically reducing the total number of crashes. So this is giving you a better estimation how your safety treatments have been, whether it was effective or not. Now I'd like to start a quick demo about with our software. I see we may have like 15 more minutes, so we should be able to finish the demo. So our system, I would like to show some of the database management capabilities that we have for our software. Then I will show you some of the network screening technique and some diagnosis and project composition. So when you log into our system, you actually need to provide your ID and password. So we ensure the security and for the users. Once you log in, let me put my correct password. Okay. Once you are in the next screen, basically you have a selection for your department and the security profile. And this department and security profile actually controls the access to different windows. For example, if I log into billing district, I have a couple of selection here. I can log into billing district, or I can log into the entire organizations. So if I log into a specific district, it will basically do a filter on my crash record or on some of the asset records. So I'll be only able to see a fraction of data instead of the whole picture. Similarly, we have the different security profiles, so you can control the access to different windows. Like if you have a system role, you virtually have access to all the windows. But if you have some other role, we can have a reduced access to some of the windows. And that helps you create different profiles and distribute the software in your agencies to use by using different profiles. So once you log into the system, the first thing you will notice that there is a dashboard in our system. The first thing, so I logged into the safety module, and in this dashboard you can put different types of report. And the report that you'll be using on a day-to-day basis, that will be in the dashboard. And now let's talk about the safety database management. As you can see on the screen, we have all these step that I showed you on top of the screen. We have the database, the network screening, diagnosis, countermeasure selection, safety projects, reporting capabilities. Those are all on the top of the screen. So it's very easy for the end user to navigate, and they can actually start from the left-hand side and go all the way to the right and to get the safety management practices done pretty much. So let's show you what we have for the database. So in a database, we have the crash data. We can have also the animal pickup data, different MIRE elements. It can be the segment element, can be the network intersection or approach data, can be RAM data. We also have citation data, and there will be a specific setup for each of the data elements too. So let's show an example of how the comprehensive crash information is stored in our system. So when you log into this specific window of the comprehensive crash information, you will see that we have different tabs. So the first tab is showing you the crash data, and the other tabs are showing you the related information. Like if I select the crash record here, if I go to person tab, it will show me the person involved in that crash. And we also have the capability that you can also see both the grid view, like you can see all the information in one screen, or individual information can also be shown in a from view. So you can have it detailed information about the crash. And you also have the crash image. So if there is any image of the crash you want to store, that is also possible. And on the front end, at the top of the screen, the date range that actually controls how much information you'd like to see. So right now it's showing you the crash between January 2014 to 1st July 2014. On the same screen, you can also do a different other types of things. You can do sorting, filter, or you can show on map. Like for example, this particular screen, particular crash, you can right click and show on map. Basically, the screen will open a floating map and it will pinpoint the crash location. So you will have a better understanding where the crash located. You can see that this happened right here. Or you can do some kind of filter. For example, I want to see all the crashes that happen on the billing city only. So you can right click and filter. We also have something called filter by this value. So it will pick up the value, assign it to the filter. If you click OK, the system will only show you the crashes that is on in the billing city. So you can do different types of filter of any of the attributes in the data pane that you can use for that. Okay, let's move on to the next item in the MIRE elements. Let's show you how we are storing the MIRE information. Like segment, for example, the segment element. This is an example from Montana. So the way they are capturing the information, they created 3 different databases: one for the segment, one for the intersections, and one for the ramp. So this is also coming from by an interface. We have different attributes of MIRE elements that are part of this table, and you can do any kind of query, or you can use directly this data in our network analysis or network screening too. Let's show you some snapshot about the safety network screening, our next component. In the network screening, I already mentioned there are a couple of items. We have the profile management. So profile management basically actually creates your profile for any diagnosis or any screening. So what you can do, you can create a profile. You can right click and insert a profile ID, identify the profile ID. You can also identify the screening method, like whether you are willing to do sliding window or peak search method. We have all these options. And then you can select your extent. Like you can do your selection for a single route, or you can do this. You can create this profile for the overall route. So we have this flexibility. Then you can identify the window length and step that is applicable for the sliding window technique. So once you run the profile, system will generate both your main profile locations and the secondary profile locations. And as you know that in the secondary profile location, basically, if it is the sliding window technique, like for example, this particular example, I have 1 mile window with 0.1 mile steps. So as you can see that the information right now, this is 1 mile window, and there's a 1 mile, 0.1 mile step. So the first segment is from 0 to 1 mile. The second segment is from 0.1 to 1.1 mile. So basically, we run this profile management, and we store the profiles first in the system. And this information can be retrofitted into this next step, which is the network screening step. So in the next step, the screening technique or screening network screening, we basically create, as you can see, there are 4 different panes in the network screening window. We have the screening scenario window on the left-hand corner. We also have on the right side the main location results and the secondary location results. And we also have the threshold selection criteria right here. So when you're running a specific screening, you'll basically insert a specific screening, and you can name the screening. Like for example, this is specific screening for 2015 HSIP project. You can identify the year of ADT, what are the safety profiles that you are using, and you can also identify the crash filter, like whether the crash filter whether you are interested to run a crash filter on the total crash or is a specific roadway departure crash. You can identify that, and the crash filter can have different types of other values. So then you have to specify the date range for the crash, your analysis period. Then you basically load your profile, and the system will compute the performance measures for different values that you already identified. And finally, when you calculate the level of service of safety, if that is based on EBA method, it will compute the empirical base method. By the empirical base method, it will adjust your estimated crash count, and finally, it will identify the hotspot. And your hotspot will be all stored in this specific tab. We call it hotspot, and this information will move on to the next step, which is your diagnosis. So once you are done with this step, which is the network screening, you start doing you use your hotspot screen results and start doing the diagnosis. And you can see there is a checkbox, like if you want to do in-depth analysis for some of your hotspot, you can check this box, and that information will be available in the diagnosis tool or in the diagnosis analysis tool. So the next step is diagnosis, and I mentioned in my presentation that there are 3 different ways you can do the diagnosis. The first one is a GIS based. So the way it works, it basically has on the left-hand side, the window has the list of all the hotspots by the screening. So this is scenario 11. I done a screening on that. I can also switch to a different screening, like this particular screening. And when this is showing you the list of the hotspots, so this particular roadway has like 83 different hotspots identified. Once you're selecting an individual hotspot, this system will refresh and it will show you the hotspot on the map. And the beauty of this system is you can add additional layer to that, like crash layer or other infrastructure layer to the same map, and can do a in-depth investigation of that. Also, if you select multiple record on the left-hand side, the system will refresh and it will show you the hotspot that has been identified. And you can either do like that, or maybe you can consider on that specific one hotspot. But either way you do that, it will give you a comprehensive picture about what is going on with that specific sites. So once you are done with the hotspot by the GIS method, you can also perform another way you can do the diagnosis. We call it the road view method. The road view is actually a linear diagram. So the way it works, it has also multiple panes. On the left-hand side, it basically shows you all the route in your network, and you can. So right now, this is showing you I-90. Basically, this is the total mileage. What you can do, you can concentrate on a specific area. So suppose I'm interested to see only from mileage from 100 to 150. You can specify that. And after you specify that information, you can select what are the different attributes you want to display in your line diagram. Like I'm interested to see the crash count, individual crash count. I also want to see the hotspot and the segment elements, which is the MIRE element, especially the number of lane I'm interested with. You can add additional layer, like I want to see the shoulder width or other types of things that can be also added here. So once you add everything, you can right click and show the linear diagram. Basically, the system will show you a line diagram feature. So you can see that the specific pink line, this is basically your segment inventory, the MIRE element that I showed earlier. And since you run different hotspot scenarios, so each of the scenario are right there. So for example, this specific scenario, this is for injury model 2011 to 2013. So you identified this hotspot. You can have another scenario. You can have a different hotspot selection. So you can see how your locations are changing from year to year, whether you're getting benefits or by implementing your safety measures or not. Then you also be able to see the individual crash. So for example, in this particular hotspot, I really want to investigate what are the different types of crash we have. So as you can see that this specific location has a lot of the rollover crash. It also have this specific slot, for example, have a increased number of the non-fixed object or debris type of crash. And if you're interested, you can actually select the specific record and can show the information. So basically, the system will show you the in-depth information about that individual crash record too. So either way, you can do an in-depth investigation about your hotspot and can make a better decision on the countermeasure selection. The third thing I mentioned in the diagnosis was the diagnosis analysis, and that was a new tool that we developed. The diagnosis analysis we also call this analytical diagnosis. The way it works, it basically lists all the hotspots that you identified, and you can also bring additional data elements to that, maybe intersection, ramp, the segments, or other component of your inventory that you can also bring here. So whenever you are selecting any records, basically it is showing you the distribution of the crash based on a specific diagnostic factor. Like in this specific example, I'm showing you the distribution of crash type, like what are the different crash types that I have for this specific location. If I switch to something else, like what is the different types of crash type by weather condition to show you that. How about lighting conditions or severity? How about lighting conditions? So all these factors will be there, and you can actually increase that, how many factors you want. That is also configurable by the end user. Now, each of these assets, right now you're looking at the distribution for one single component. You can also go to the group distribution. Like, for example, the specific road, I can see the roadway type is major collector. So if I switch my functional class to major collector, it will give you an estimation about the distribution of different lighting conditions for all the major collector road. So you can basically compare this, and we also have a group comparison window. So basically it shows all the factors, like what is the percentage of distribution for a specific factor, and what is the distribution of the group that you are selecting here. And you can like look at the color coding. Like if it's a red, then there is some issues with that. Like for example, this one, you have a fixed object crash, and for that specific location, 23.5% crashes are like that. But if you compare with the roadway type, which is the major collector, the percentage is 17%. So you can investigate. You can say, okay, there are a lot of fixed object crash, so that side might have some issues with that. Similarly, like wild animal, like there are 32% of the crash, whereas the average for this for the functional class is 7% only. Similarly, this one, take a look. Access control, there is no access control for this roadway, and that's why there are 56% of the crashes happening at that point, whether the average is actually 50%. So you can compare all these and the decision, like when you'll be flagging that location, what should be the criteria, that is also the agency decision. It can be maintained or specified by you. Let's take a quick look about the next thing, our project composition window. So once you have this diagnosis and you pinpoint the issues and you identify the locations, then you basically go and start plugging them in the project window. So before that, we have another window in the intermediate screen where you can actually have your treatment options. Like for example, this is a treatment library that Montana is using. So you can, for your agency, we'll have a similar screen. So you can have all the different types of countermeasures that you would like to use in your safety projects, and the different types of cost involved with that. What is the year of investment, dollar value, the crash modification factor or crash reduction factor, what are the specific crash type the treatment is will address. So all the information will be in a treatment library. Finally, in the project selection window, in the project composition window, you basically start with a new project, like you insert a new project, and you basically insert the project from your shortlist. So as I mentioned earlier, that you did your diagnosis on different hotspots, and you have identified whether those hotspots will be part of your projects or not. So if you want to insert any new any project location, basically you can insert the location from that shortlist. You can pick up a location, can add the location in your project, and then you can also add treatments to the projects. And one thing I would like to mention that our system allows you to add multiple treatment for a single locations, or it also allows you to have multiple project location for a single project. So it's a versatile solution, and the benefit and cost calculation will be also conducted at the location level. I can see there is a benefit and cost at the project level, at the location level. We also have a benefit and cost estimated at the project level too. So we have that flexibility or versatility of the benefit and cost analysis. And I also mentioned you about different projects, other types of project tracking tool that we have. One example is like if project is in the project composition window. If you move on to the next step, then there will be a different window screen for that. So in the recommended project step, you can add your project phase and can also add the HSIP funding for that and can do a detailed investigation using that. So at the end of that, eventually you'll come to the completed project step and can do the benefit and cost analysis using the tool that we have in that specific window. So in a nutshell, we have all this capability in our system. So it's a complete package for the safety management. I have used most of my time. I'll probably use 1 minute just to show you the roadmap of our software. Then I will leave it for the question and answer session. These are the demonstration topic. Okay, the roadmap. So our plan is to have a SPF calibration capability in our system. We were seeing the growing demand of that, so we'd like to implement that in our future solution. We would like to improve our road view and line diagram. We want to also improve the safety long-term planning. Currently, the safety planning that we have, we implemented for Israel. That does for single year. We want to have multi-year long-term planning. We also want to include or investigate if there is a possibility to have a collision diagramming tool in our system. Although our GIS viewer is very useful and to some extent that is meeting the need for the collision diagramming tool, but we also like to see if there is any way we can include that in our software. We want to also want to improve the business intelligence platform, like maybe like Oracle BI or some kind of reporting capability. And our ultimate goal is also to have a spatial analysis tool. So more like a cutting-edge technique like spatial distribution model or buffer analysis, we also want to include in our software foundation. So with that, I'd like to conclude my presentation, and I'll just wait for your question if you have any questions at this stage.
Yeah, are there any questions from the group for Shafiul? Just type them into the Q&A tab in the WebEx window. No questions? Well, I don't see any questions coming in. I guess we will wrap it up then. If you have any questions, please feel free to email us. You can email me at braskin, B-R-A-S-K-I-N, at AgileAssets.com, and I'll make sure that Shafiul and I get any questions that you have, get the answers back to you. With that, as we say thank you, I want to remind you there is a webinar survey as you log out. Please take a moment. There's only like 3 questions on it. If you could fill it in, I'd really appreciate it so we can improve these webinars going forward. And we look forward to having you participate in one of the upcoming AgileAssets Product Showcase webinars coming up. So thank you very much and have a good afternoon.